Welcome today. Well, we're gonna see the problem for a binary tree. Well, the problem say this. Show that if a node in a binary search tree has two children, then its successor has no left child and its predecessor has no right child. Well, let's first see how to find the successor and the predecessor of a node we choose. Well, when we want to program something, we need to send instructions. Here we can say that, well, the predecessor of 10 is 8 and the successor is 12. But how do we put that into a code? Well, to put that, let's think that we choose 10. So we first gonna see how to find the successor of 10. Well, it's a condition. If the right subtree is not null, go right. Okay, here is. So we find the successor. Let's try with another one, like 7. We first go right, and then if it had another child here, note, you need always to go to the left. Now, so it's right and all the way you can to the left. So we 8. So the successor of 7 is 8. That's correct. Now, what happens if, for example, the successor is not directly like this? Let's think we choose 8 this time. So, if right sub 3 is null, we first need to go to root. If this node we choose, that is 8, is greater than the data here, we need to go to the right. Else, we need to go, if it's false, we need to go to the left. So let's see, 8 is less than 14, so we need to go to the left. Now 7, 8 is more than 7, so we need to go to the right. Now 8 is less than 10, so we need to go to the left. We find 8. So the successor is the last one that is higher than 8. So this time is 10. These are two ways to find the successor. Well, to find the predecessor is the same, but in the other way. You only change right and left. So let's see an example. Let's now turn again 10. Now, the predecessor of 10 is 8, so it's the same. If left sub 3 this time is not null, we need to go to the left, so it's 8, correct. Now with 14, let's try it. 14. We first need to go to the left, because there's a child, it's not null. Now we go all the way we can to the right, so right and right. Now it's 12. 12 is the predecessor of 14. So that's correct. Now, the other case we have that the sub 3 is null. So let's, I think, again with 8. So 8. We have no childs. So let's go again to the root. And then let's see now that is less. That if 8 is less than 14, we need to go to the left, otherwise to the right. But this time it's less, so we need to go to the left. Or 8 is less than 7? No, we go to the right. 8 is less than 10? Yes, we go to the left. We find again 8. So we need to see the last one that 8 is higher than that data. So in this case it's 7. Okay, so we find that 7 is the predecessor of 8. Well, now let's see what happens with this question. Show that if another binary search tree has two children. So we suppose right here that the node we're going to choose had the two children, one to the right side and one to the left side. Then its successor has no left child and its predecessor has no right child. Let's see very quickly. So let's see that we choose 10. It has two childs, one left and one right. Now the successor of 10 when we choose is 12. So 12 has no left child and not right child. A predecessor of 10 here is 8. No right child. So that's correct. Now see like with 7. 7. It has two children too. Now let's see the successor has no left child. The successor of 7 is 8. No left child. Now the predecessor of 7 is 6. It has no right child. So that's correct. Well, now why is this happening? Well, for any node, the successor is the leftmost element of the right subtree. Well, if it exists, this subtree. It is given in the problem that right child exists. So the successor is the leftmost child in the right subtree. Evidently, most child cannot have a left child. Well, in the similar way, the predecessor is the rightmost child in the left subtree, and rightmost child cannot have a right child. Like, let's see with the example 14. Like we say already, the successor of 14 is 15. It has no left child. And this predecessor of 14 is 12. It is the biggest node or data in this subtree. So we'll see that it has no right child. It cannot have a right child. So we can show that this is correctly in all the ways. Well, thanks for your attention and goodbye.